Hello everyone. This video serves as a tutorial and documentation for version 3 of my Blender geometry nodes pipe, cable, and bridge generator. I'll go through each option on the node group here and explain how it works and how you can get a good result out of it. The base mesh input is where you will connect your geometry nodes system in the node setup, just like you would any other node in the geometry node system. Master random seed is the randomization parameter for most functions in the node group, so this will allow you to randomize the behavior of the output. By enabling sequential mode, you can change the behavior of the node group from connecting random vertices or faces to connecting each vertex or face in the order of their index. This is internal to the mesh data itself, so if you're trying to get a sequential behavior in a controlled manner, it usually works best if you create the mesh specifically for this geometry nodes setup. Generate on base mesh faces will toggle generating geometry on the faces of the base mesh rather than on the vertices. This can often give better results when you're using a planar surface, as it avoids generating on the outside edges of the base mesh. Manifold complexity is your primary input that you'll use to adjust the number of pipes or cables that are being generated. As this number increases, you'll get more pipes or cables generated, and in a generally more complex manner. However, if you increase the complexity too high, it can create some undesirable effects, such as numerous pipes all connecting to the same stem. If you set this value too low as well, then most likely you won't have enough geometry generated to work with. Manifold density affects the number of pipes and/or cables that are generated. This is your primary input for quickly adjusting this value, but it is also affected by the manifold density reduction factor. If this reduction factor is very low, your density will be quite high, and so you'll get a lot more pipes. However, this can cause excessive mesh density on smaller base meshes. Max bridge distance allows you to specify an upper limit to the distance over which the node group will attempt to connect two stems. Any stems that are further away than this value will not be connected with a pipe or cable. However, the stems themselves will still be generated. You can set this value to 0 to disable it. Minimum bridge distance is similar to maximum bridge distance in that this is the shortest distance over which to attempt to connect stems. Any stems that are closer than this value will not be connected, but they will still be generated. And also you can set this value to 0 to disable the feature as well. Pipe, cable, stem radius is the diameter of the pipes, cables, and stems that are being generated using the built-in features of this node group. This will not affect custom meshes that you're using as part of the node group. The pipe, cable, stem loop resolution option controls the number of loop segments to generate for each pipe or cable. Reducing this value can reduce your overall mesh density, but will produce less defined cables and pipes. The selected material under pipe material will be applied to all generated pipes. You can use the attribute shader node to access the UV coordinates of the generated pipes by using the UV map attribute as shown here. This allows you to texture the pipes along their actual direction. The Shade Smooth switch allows you to toggle smooth shading on all generated meshes. Minimum stem height will be the lowest height that generated stems can have. This value can also be less than 0, and this value does affect custom stem meshes. Maximum stem height is the greatest height that generated stems can have. This value can also be less than 0, and it does affect custom stem meshes. The stem height variance affects the randomness of the heights of your generated stems. The higher this value, the greater the variance in generated heights. If you set this value to 0, all the stems will have 0 height. To make all stems at the same height, set the minimum and maximum height inputs to the same value and set this variance input to 1. This input also affects custom stem meshes. Override stem alignment mode allows you to manually specify the direction to which generated stems will be aligned rather than the base mesh face normals. If for any reason you're having issues getting the stems to face the right direction, or if there's some issue with your underlying base mesh, you can use this value to force the stems to generate in a specific orientation. This is also useful when you're using this node group with a base mesh consisting solely of vertices and edges. Set this value to 0 to disable it and use the base mesh normals for orientation. The material selected under pipe stem material will be applied to all stems generated that are connecting to pipes rather than cables. This material can also reference generated UV coordinates through the use of the attribute shader mode, as discussed in the pipe material input. Use custom stem meshes can be enabled to use custom meshes instead of cylindrical stems. These instances will use the source mesh properties including materials. Stem mesh collection specifies the collection from which to pull custom meshes to use when generating stems. Create a collection to use for this input and place your custom meshes in that collection to use them with this node group. When randomized stem meshes is enabled, the node group will randomly pick a mesh from the specified collection to use at each stem instance. Custom stem scale will specify the scale of the generated custom stem meshes. Custom stem height will specify the height of generated custom stem meshes, but this does not override previous stem height controls. So if you need to make sure that your stem mesh is properly scaled, this input allows you to make some more adjustments to the height. The Use Cables switch will toggle generating cables instead of pipes or bridging meshes. Note that this input will override the generation of bridge meshes even if the cable percentage is set to 0. If you'd like to generate both pipes and cables with this node group, you can do that by specifying the cable percentage input, which will determine the percentage of generated meshes that will be cables and the rest will be pipes. Note that this currently does not allow you to use cables and bridging meshes. Rather, it only works with cables and pipes together. Cable random seed value will randomize the position of each of the cables. The cable X, Y, and Z randomization inputs affect the randomness that is applied to the generated cables in those respective directions. The cable randomization scale input multiplies the randomness of each cable in each direction, and changing this value allows you to make significant adjustments to the shape of the generated cables. Restrained cable variance lets you make the cables slightly more uniform in their generated positions. The cable hang direction vector allows you to specify the direction towards which cables will hang. For example, to make the cables hang downwards in the scene towards -z, the input would be 0, 0, -1. Note that greater absolute values will have a more significant effect, and smaller absolute values may not be as noticeable. In this example, you probably will need to have a value greater than -1 to get the cables to hang realistically. Cable resolution determines the number of lengthwise segments of each cable. Higher values of this input will allow you to create smoother cables, but might result in excessive mesh density if you crank it up too high. Whereas if you make this value too small, you're not going to get as smooth of a generated cable, but you'll have a much lower mesh density. The cable sway keyframe input allows you to animate the cables swaying back and forth. To do so, you can either keyframe this value, add a driver to this value, or connect a scene time node to this input. In my testing, I used the seconds input and it worked pretty well. Note, though, that adding the scene time node, even if it's not connected to anything, will slow down the scene to some extent. Cable sway factor determines how far the cables will be swaying from their starting positions. Cable sway speed affects how fast the cables will sway. Extra cable sway randomization allows you to have additional random behavior in the cable swaying motion. Enabling cable Z sway causes the cables to sway up and down as well as the default side to side. This might be useful depending on your application, but it does look a little bit less realistic when you have cables hanging downwards. The cable material specified here will be applied to all generated cables, and as previously mentioned, this material can use generated UV coordinates to the use of the attribute shader node with the UV map attribute. Cable stem material is applied to generated stems that connect to cables. And again, the specified material here can use generated UV coordinates for stems in the same manner as previously discussed. Generate stem flanges enables generation of flange meshes at the base of all stems. Flange type will specify the type of built-in flange meshes to use. You can switch between round, square, or spherical flanges using this input. The flange width factor input affects the size or diameter of flanges as a factor of the pipe or cable diameter. Flange height affects the vertical size of generated flanges, with the exception of sphere flanges, which will displace the flange along the stem. Flange material is applied to generated flanges. The generate flange rivets input allows you to generate small rivet meshes on the upper surface of flanges. The rivet size factor input affects the size of the generated rivets. Rivet placement affects the location of the generated rivets as a function of the radius of the flange. In other words, a 0 input for this value will generate rivets at the center of the flange and stem, and 1 will generate rivets at the outer radius of the flange. Rivet count determines the number of rivets to generate on each flange. Rivet subdivisions determines the number of times to subdivide rivets for smoother surfaces. Note that for a high-density mesh with a lot of generated stems, there may be a significant number of rivets, and so increasing the subdivision value could quickly result in excessive mesh density. By enabling Use Custom Flanges, you can specify custom meshes to use instead of the presets for flange generation. These instances will use the source mesh properties, including materials. The flange mesh collection specifies the collection from which to pull custom meshes for generating flanges. Use bridging meshes allows you to use custom meshes or curves instead of preset pipes or cables. Note that you must disable the Use Cables option in order for this input to work. In addition to custom meshes, you can also use curve objects as well. Bridge mesh collection will specify the collection from which to pull custom meshes to use when generating custom bridges. You can create a collection to use for this input and place your custom meshes or curves in that collection to use with this node group. Custom mesh index allows you to quickly specify which mesh or curve from the collection to use when generating meshes. This is only enabled when using non-random inputs. Randomized fill meshes allows you to randomly select a mesh to generate at each path between stems. This only functions if there is more than one mesh or curve object in the bridge mesh collection. Random mesh seed is the randomization parameter for bridge mesh generation. Use mesh bounding box is a debug option that will allow you to use low poly boxes of the same size as the selected meshes instead of the actual meshes themselves. This allows you to get an idea for what the final output will look like whilst generating a significantly less dense mesh. Uniform mesh scale can be enabled to only use the mesh scale X input when scaling bridge meshes to preserve their aspect ratio. Mesh scale X and Y will scale generated meshes in their local X and Y directions respectively. Mesh axial rotation will rotate generated meshes along their local Z direction. Number of bridge meshes specifies how many times the base mesh should be duplicated to fill the bridge path. If the selected mesh or meshes are not long enough in the local Z direction to fill the path, they'll be scaled in local Z to fit this dimension. This scaling takes place after duplication, so the number of bridge mesh input can be used to keep the scale of the bridging meshes closer to the original mesh itself. Auto-scale bridge meshes is an experimental option that will attempt to scale meshes uniformly depending on the length of the path to be filled. This does not always function correctly, but can produce some better results in certain circumstances. If you do run into issues with this option, you can sometimes improve its performance by changing the master random seed. Bridging curve mode should be enabled if you're using custom curve objects for bridging instead of meshes. Bridge curve scale determines the uniform scale of generated bridge curve objects. Enable start cap meshes toggles generating cap meshes at the start of each path. Start cap mesh collection specifies the collection from which to pull custom meshes to use when generating start caps. Start cap scale will uniformly scale all generated start cap meshes. Enable end cap meshes allows you to generate cap meshes at the end of each path. End cap mesh collection is the collection from which to pull custom meshes to use when generating end caps. End cap scale determines the uniform scale of generated end cap meshes. So with that, thank you for watching. There's a link in the description to the store page for this node group. If you do have any further questions, feel free to leave a comment and I will do my best to answer it and explain if anything that I was unclear with here. I also have a text version of this documentation as well, which is included with the node group download. As I make changes, I will also mention them in the comments in this video as well. So with that, thank you very much for watching, and consider subscribing if you'd like to stay updated on the progress of this node group and see what other stuff I'm working on this channel. And again, thank you very much for watching.